Hello, Physics 11 students. I almost said Physics 12. This is Physics 11. Welcome to the class. I will have given you an introduction in class, but welcome to the online component of this, where you're going to be watching these videos. Each lesson will be posted here. You can watch this many times as you want. I'm going to try and make sure that these videos aren't super long. Hoping to keep them all under 20 minutes. So hopefully you don't have to spend a ton of time on this. And obviously when you get to class, you can ask any questions on the material that you don't understand. So it's not expected that you understand all the content, all of it on these videos. I don't think that is going to be possible. So watch the video, come to class, and ask questions. Today, this is our very first lesson. This one's all about measurements and scientific notation. Most of this you should know already. So the purposes for this lesson, you're going to learn about SI units. Probably seen a few of them. I don't know how many you have, but most of them you probably have. And we're going to look at some scientific notation. This you for sure have seen. I'm guaranteed that you've done that. And learning how to convert between units. So we need to use SI units and scientific notation to do that. These are things you need to know. Today's lesson, tomorrow's lesson, or next lesson if it's not tomorrow. You need to know these because we're going to use these every single unit. So if you don't know measurements or scientific notation, you're going to miss out on a lot of marks. Same thing with tomorrow's lesson. If you don't know how to do trig or know how to do algebra, basically all of Physics 11, you're going to struggle with it. So these two lessons are short, but they're very important. You have to know these. So focus up and make sure you know how to do these. If you don't know, like I said, make sure you ask questions. First of all, we need to look at SI units. I'm going to give you a bunch of measurements. I'm going to tell you what the unit for the SI unit for it is and what that symbol is. So this is every time we do a measurement, say for example, length. All your lengths when you solve questions, they must be in meters. If you're given something in centimeters, you're given something in millimeters, I don't know, gigameters, something like that. You need to convert this into meters. Otherwise, it's going to be impossible for you to solve it with the equation. There are exceptions to this rule, but I want you to get it 100% of the time. So I'm going to specifically talk about that. So length is meters. The symbol is m. So if you see m behind a number, it means meters. If you're dealing with mass, it's not grams, it's going to be kilograms. So make sure you know that. That's the only one that's a little bit weird. Is mass in kilograms, not grams. Times in seconds. That one I think you know. Speed or velocity, we'll get to those a little bit later. Those are meters per second. So it's m/s. Force is a Newton. Force is just a push or a pull. We'll get to that in, I think that's unit 3. We'll get to that. And then energies in joules. That'll be after forces. So these are some main things. I'll teach you some more as we go along. But these are just a few of the measurements that you need to know. Make sure you know the units and the symbols. Again, you'll lose out on half a mark on every question you don't put a unit. So make sure that you put those. It's very important. Another thing we need to know with this is prefixes. So prefix is just a prefix. It's before. You're putting at the beginning of a word in order to add a specific measurement to it. So for example, mass that we just talked about has kilo. Kilo in front of the gram means something specific. These are going to be on the formula sheet. You don't have to memorize these ones. The measurements you do. So mega, if you see a capital M beside your unit, that means it's times 10 to the 6. So if you see capital M and then a small s, that means megaseconds. So that means whatever amount you have, you put times 10 to the 6. Kilo, 10 to the power of 3. Your base unit, so just seconds or just meters or just grams, those have no prefix, and so there's no factor to it. So 10 to the power of 0, anything to the power of 0 is just 1. So there is no factor change. Doesn't change anything. Centimeters 10 to the negative 2. Millimeters, those two you should be familiar with. And micro is this mu, it's a Greek letter, is 10 to the negative 6. These are your prefixes. These are going to be on your formula sheet. Let's look at how to go about these. All right, so scientific notation, as you saw with the last slide, we're going to have factors of 10 to the power of something in your numbers. So it's going to be really important to know how to use scientific notation, how to manipulate scientific notation. So for example, I think it's 580 billion. Yeah, 580 billion. This number would be really annoying to have to write into your equation multiple times. Easier to convert this into scientific notation. So there's a few steps. I'm going to show you the steps. It's the same every time, so you just need to memorize or know how to do this conversion. You should have learned this before, so hopefully it still makes sense. So first, we need to move the decimal point until there's only one digit to the left. So in our case here, here's our decimal. It's not written, but that's where it is. I want to move this decimal until there's one non-zero digit to the left. Put an arrow that shows we move the decimal to the left. And we're going to put the decimal between 5 and 8. So we'd get 5.8 is where we move the decimal. The number of spaces we moved the decimal is now going to be our power of 10. So if we look at our example here, the decimal moved over 11. So we're going to have 5.8 times 10 to the power of 11. And if we move the decimal to the left, then our exponent's going to be positive. If we move the decimal to the right, the exponent's negative. So in this case, we moved our decimal to the left. So our power of 11 now becomes positive. And that is this number written out in scientific notation. So let's try another example. This time we've got a smaller number. I'm not going to read it. It's written there on your screen, so you can take a look at that. It's the exact same as last time, but I'm going to walk you through it step by step. So here we go. Let's move the decimal until there's only one digit to the left. Again, it's still to the left. It's not different because it's a smaller number. We always want the decimal to have one non-zero digit to the left. So here's our decimal. Let's shift it over to the right in between the 2 and the 5. So once we put it there, we have one non-zero digit to the left. This gives us 2.56. Now the number of spaces that we moved, that's going to be our power of 10. So we moved 9 spaces. So we have times 10 to the power of 9. We just need to figure out if it's positive or negative. So again, if we move to the left, it's positive. Right is negative. In this case, we move to the right, so our exponent is going to be negative. So there is our number in scientific notation. Let's do a bunch of examples. Pause the video. Give this a try. I will wait right here. Go. Okay, hopefully you got these right. Let's take a look. I'm not going to go through these. If you have questions, come and talk to me in class. Here are your answers. So for example 3, here's that one, here's this one, here's this one. Like I said, if you have questions, let me know, but hopefully those all made sense for you. If you don't know the steps, memorize the steps. Those will help you. Now we want to do the reverse. This one's a little bit easier. If you have a power of 10 that is positive, you're going to move the decimal to the right. If it's negative, it'll be the other way. So for this example, let's take that decimal, move it to the right 7 spaces, you'll get this. Negative, you move the decimal to the left. So in this case, you take the decimal, move it 2 spaces to the left, you get this. Hopefully those ones make sense. Now let's do some unit conversion. This is basically a combination of the other 2 sections. So we've got 290 kilojoules into millijoules. There's a process to this. It's not overly complicated. What you're going to do is you're going to take your known prefix and you're going to minus from that your unknown prefix. And this is going to give you your power of 10. So let's take a look at this example. Our known prefix is kilo. It's kilojoules. It doesn't matter if it's joules, meters, whatever. We just need to know the prefix. Kilo, our unknown is milli. So we want to know what these values are. So if you look on your formula sheet or that conversion table that I showed you at the beginning of the notes, kilo has a power of 3. Milli has a power of -3. We're going to subtract these 2 values, and that gives us 6. So 6 is going to be our power of 10. We take a look at our original question. We had 290. Now we're going to times this power of 10. Now we're not done yet because this is not proper scientific notation. If you notice, the number in front has a value that's bigger than 10. So in this case, we're going to convert it like this. Again, if you want to convert this into scientific notation, go back to the other methods. You take the decimal, move it to the whatever space, and that gives you an extra power of 10. So 2 things, don't forget to simplify. So if you put 290 times 10 to the 6, this is not correct. I wanted proper scientific notation. And the other thing is don't forget the units. If you don't put units, you're going to lose half a mark on every single question. Let's do another one. So we got 75 megameters into centimeters. So again, remember our equation, known prefix minus our unknown prefix is going to equal our power of 10. So in this case, our known prefix, mega, has a power of 6. And we're going to subtract from that our centa, which is -2. So we get a power of 8. 75 megameters. So we're going to take 75 times 10 to the 8. Again, this is not proper scientific notation. We need to take our decimal from behind the 5, shift a 1 to the left. This will give us 7.5 times 10 to the 9 centimeters. Again, don't forget, proper scientific notation. So don't leave it as 75 times 10 to the 8. And don't forget the units. Very, very important. You do these 2 things. So pause the video, give these 2 a try. And I'll see you in a couple minutes. let's take a look and see how you did. Again, we're converting from centi into kilo. So this is our case here. Our power of 10 is going to be -5. We take our original value times 10 to the -5. Again, don't forget, we need to convert this into proper scientific notation, and we need the units. So there's the answer for this one. For the next one, this one was a little bit trickier because seconds had no prefix. So if you didn't realize that, there's no power. So it's just 0 minus mega. This one you know, so we have a power of -6. Again, this one was again tricky because we already had its scientific notation. So what do we do with this? Well, we write it out, our original number times 10 to the power of our new power. And hopefully you remember the exponent laws. 10 to the 3 times 10 to the -6 gives you 10 to the -3. So there you go. Okay, one last converting units problem. This one is meters per second to kilometers per hour. This one is going to be quite common, so let's take a look at this. The problem now is I'm not dealing with a single unit, it's meters and seconds into kilometers and hours. So we're going to use a trick that maybe some of you learned in chemistry called unit analysis. So 4.2 meters per second. I want to get rid of meters and turn it into kilometers. So 1 kilometer is 1,000 meters, and I put the meters in the denominator so that my 2 meters cancel out. That's how you know you're doing this right. Now, if you take a look at our units, once we've divided by 1,000, we've got kilometers per second. Again, that's not what we want. We want kilometers per hour. So I need to get rid of seconds. So there's 60 seconds in 1 minute. Again, I know I've done this right because my seconds is in the denominator, cancels with the seconds in the numerator. Now we've got kilometers per minute, not quite there. We need it per hour. So we get this last step, we cancel out the minutes. Now, if we do this whole multiplication, so 4.2 divided by 1,000 times 60, we will have kilometers per hour. Now, this is a long process, and I don't want you to do this for every single question. So what's going to happen is I'm going to give you some conversion on your formula sheet. You're going to have this. This is copy and paste from the formula sheet. So if you tried that for this question, if you did 4.2 times 3.6, you'd get our 15.12. If you need to know where that comes from, I can show you in class, but really it's not overly complicated. All right, so that is the very first lesson. I hope that that was pretty straightforward for you, and it's mostly just review. You need to make sure you know this. Like I said, this is going to come up in every single unit, in every single question. Make sure you know this. All right, welcome to the after lesson video part. This is probably my favorite part of doing these videos is after each lesson, I'll give you a little bit of something special, something that's more fun, something that I was going to say not related to physics, but I chose to do something that is related to physics. If you watch my Pre-Calc 12 next year, you will see a lot different stuff than what I'm going to do this year. What I thought I would do this year is take a look at physics in movies and show you a video clip from a movie, and then you decide if you think it's true physics or if there's something that is not correct with the physics. It could be any part of the video. I thought this would be fun, challenge you to think about what physics actually looks like instead of just what you see in the movies, because often what you see in a movie or a TV show just messes with the reality of what happens with physics. So I'm going to see if I can find videos for each lesson. We'll see if I can actually do that, because that's going to be a lot of things to look for. But I will try and do that. We'll start with this video, so I'm going to show you a clip. You need to guess if it's true physics in the video or not true physics. Once you get further along, maybe you'll start to understand why, hopefully. And then maybe you won't like that I keep doing this. Maybe you'll want to skip these sections because it's just going to ruin some movies for you. I know it has for me, just saying like, yep, that just doesn't work. So that's what I'm going to do. All right, so here is your very first opportunity to guess if the physics in this video clip is true or false. This one's from Looney Tunes. If you know Looney Tunes, this is a Wile E. Coyote where he's chasing after the Roadrunner. A whole bunch of stuff goes wrong. That's just the whole point of this cartoon. Take a look. I will play this clip. You need to guess, is this true physics or false physics? right, so what do you think? Was this true physics or false physics? I'll give you a sec. If you said that this was true, you are completely wrong. This is very false for many different reasons. And I will show you a few things why. So first of all, this part where he is tying the motor into a boat and pushing backwards, this makes absolutely no sense why this would work. Notice here, if we're talking about forces, yes, this motor is pushing the water back to the right, but that water is then getting pushed against the back of the tub here, which will stop him from moving. So this doesn't work. He's not actually going to be going anywhere from that. He'd have to be pushing against the ground, which is going to stay still in order for that to work. So that part definitely does not work. And then the part that makes well, this is cartoon physics. This is totally what happens. There's no gravity. Look, he's just traveling straight sideways. It's as if he's not going to fall. That's the only thing that's happening. And then as soon as he unties it, the rope falls. That's the only thing that gravity applies to. He's like, oh, I am gonna fall, but before I fall, I'm just gonna think for a sec. No gravity. The cart keeps on going as if there's no gravity applied to that. It just moved in a straight line. You realize, oh, this is gonna hurt. And then gravity's there. And then that's it. So there you go. That's the first one. Hopefully this is something that's enjoyable as we move on into the different lessons.